Remember Francine dropping her baseball from the top of the cliff? Now Fred is at the top of the cliff. He thinks that if he throws the ball very quickly, he can keep it in the air longer than Francine. If you remember, Francine's time was 10 seconds. Fred throws a ball with an initial velocity of 20 meters per second horizontally. How long does it take to fall? When Francine's ball dropped straight down, we only had to consider one dimension, the y direction. But if Fred throws the ball horizontally, it's going to move in the x direction and the y direction. This makes it a projectile. A projectile is an object that moves in two dimensions under the influence of gravity and nothing else. Just like free fall, we're going to ignore air resistance. If we looked at the motion of the ball over time, this is what it would look like. To understand projectile motion, we're going to break it into horizontal and vertical components. In the horizontal direction, his velocity vectors at each point look like this. You'll notice that the magnitude of the horizontal velocity vector does not change over time. This is because there is no acceleration in the x direction. There's no air resistance to consider, so it will have the same velocity that he started with, 20 meters per second. In the y direction, his velocity vector will look like this. Just like in free fall, his velocity will increase over time. That's because in the y direction, there is an acceleration. It's the acceleration of gravity, making it speed up in the y direction. The resultant vector is the sum of the two vectors, of the velocity in the x direction and the velocity in the y direction. So your resultant will look like this. If we add this vector plus the other vector, so his overall velocity vector is the red lines. The first rule is that the horizontal and vertical motion are completely independent of one another. That means the velocity in the x direction will not affect the velocity in the y direction. We can treat the x direction and y direction independently. In the horizontal direction, or the x direction, the acceleration is 0 meters per second squared. There's no acceleration in the x direction. As a result, the velocity in the x direction, which we write v sub x. The subscript just says we're talking about velocity in the x direction. V sub x is going to be a constant throughout the projectile. So from the time he throws the baseball until it hits the ground, its x velocity will be 20 meters per second. In the y direction, the vertical motion, our acceleration we write as a sub y. Our acceleration is going to equal gravity. Acceleration in the y direction is negative g. It's negative 9.8 meters per second squared. This is always true for basic projectile motion. We're not considering being on the moon or other places where the acceleration may be different. But for basic problems on Earth, our acceleration in the y direction is always negative 9.8 meters per second squared. Because there's a acceleration in the y direction, v sub y, or the velocity in the y direction, will change over time. The velocity of the object in the y direction, right before it hits the ground, is not 0. After it hits the ground, we're going to have a collision and the velocity will change. That is not going to be considered in a projectile motion question. But before it hits the ground, it's a very large velocity if it's dropped from a high point. Let's go back to our original question. Fred throws the ball, but he's going to throw it horizontally, whereas Francine just dropped it. He throws it with an initial velocity of 20 meters per second horizontally. How long does it take to fall? We're going to solve this problem the way we've been solving problems. We're going to start with listing our givens. For projectile motion problems, list horizontal and vertical motion variables separately. That way you don't mix up what's the horizontal motion with the vertical motion, since they are independent. So we'll make two columns, x direction and y direction, and now we will list our givens in each direction. In the x direction, we know there's zero acceleration. The initial velocity is 20 meters per second, and that velocity doesn't change. So the final velocity in the x direction is also 20 meters per second. We can define the initial position in the x direction as 0 meters. In the y direction, we know the acceleration is gravity, negative 9.8 meters per second squared. He threw it horizontally, so there was no vertical velocity to start. He didn't throw it up or down. So its initial velocity in the y direction is 0. It's not moving up or down at the beginning. That will change with time. His initial position we can define in the y direction as 0. And from the last video, the final position will be the bottom of the cliff, which will be negative 490 meters. We'll assume that this ground is flat. There's no hills at the bottom. Now you'll notice I put time between x and y. The time to get to the bottom is going to be the same for both of them. So the t in the x direction equals the t in the y direction. So if we look at the x direction, we want to find time. With the variables we have, we're going to have a hard time using an equation to find time. If we use the first equation, we'll find that this is 20 meters per second, this is 20 meters per second, and this is 0. So because acceleration is 0, we won't be able to use the first equation. If we look at the second equation in the x direction, we don't know the final position, and we don't know time, so this equation won't work either. Our third equation in the x direction will give us 20 squared equals 20 squared plus 0. Again, we won't be able to solve for time using this equation. So to solve this problem, we're going to have to use the y direction. And based on these variables, I'm going to pick the second equation. Now I'm going to plug in what I know to solve for t. Our final answer is the time it took his ball to fall is 10 seconds. Well, that's interesting. That's the same time it took Francine's ball to fall. Why is that? Well, think about how the x and y motions are completely independent. So both of them started the ball in the y direction without movement. He started by throwing his in the x direction, but that doesn't affect the rate at which the ball falls. So his ball will take the exact same time as her ball to fall to the ground.